Hi everyone. Today we'll discuss determinants. Determinants is a very easy topic. I will say the property according to the problem. Okay, show that 1, 1, 1, A, B, C, A square, B square, C square equal to A minus B, B minus C, C minus A. So this we have to show. So write down right left hand side 1, 1, 1, A, B, C, A square, B square, C square is there. Now what we are doing? Row operation. R1 implies R1 minus R2 and R2 implies R2 minus R3. R1 implies R1 minus R2 and R2 implies R2 minus. This is row 1. This is the first row, second row, third row. This is first column, second column, third column. So R1 minus R2, 1 minus 1, A minus B, A square minus B square. Now R2 implies R2 minus R3. 1 minus 1, B minus C, B square minus C square. 1C, C square is there. This will give us 1 minus 1 is 0, 1 minus 1 is 0, 1. A minus B, this is B minus C, C. You see, remember A square minus B square, we can write same as A plus B into A minus B. Similarly, B square minus C square, we can write B plus C into B minus C. So this I am writing A minus B into A plus B. And this is B minus C into B plus C. And this is C square. Now this will give us 0, 0. So what I am doing is here from the first row I am taking A minus B common. From the second row I am taking B minus C common. Okay. So first row A minus B I am taking common. From second row B minus C I am taking common. So this is 0, 1. A minus B already we have taken common. So A plus B is left. 0, B minus C we have taken common. 1. So B minus C. So here B plus C is left. So 1 C, C square. 1 C, C square. Now what we are doing is expanding by column 1. Is because there are two zeros. So only one will be there. Expanding by C1. So expanding by C1. This will be A minus B, B minus C. 1. This, if we expand by C1, what will happen? If we expand by C1, what will happen? You have to leave this row and this column. This column and this row. What is left? What is left? This into this you have to multiply. So B plus C and 1 time minus AD minus BC. B plus C minus A minus B. Minus B minus A getting cancels. So this is A minus B, B minus C, C minus A. Suppose if you consider this as left hand side, so this is our right hand side. We have proved this thing. He said show that. We have showed that. It appeared in April, May 2023. This problem. Please do remember. Very easy. Just and please remember, you can go row application or column application at a time, not both. Not both at a time. Either you have to go row application or column application. One more problem. One more problem. without expanding, show that determinant of 41, 79, 29, 175, 593 equal to 0. Without expanding, you have to do. So left hand side equal to, what I am doing is 41. I am writing 41, 5 times 8, 40 plus 1. So this is 9 times 8. 9 8 is 9 8 is 72. 72 plus 7 is 79. Then 3 times 8, 3 8 is 24 plus 5. See here, according to this, in terms of 5, I am arranging this. This was 5 times 8 plus this. This is 175, 593. This is given. Now what we are doing? You see 5 times 8, 9 times 8. This I am consider as one row. This I am considering as one row. One term. Sorry, one term. Not row, one term. So 3 times 8. 175, 593 plus this I have already used. So what is left? 175, 175, 175, 593. See here, what the rule says? The rule says if two rows or two columns are identical, then the value of the determinant is 0. So this means 175, 175. Two rows, two columns are identical. So therefore, the value of the determinant is 0. So without expanding, we made that is 0. Now the next one. You see 5, 8, 9. I am taking 8 common. According to the properties of the determinant, you can take 8 common from a row or a column. So I have taken 8 common. So 593, 175, 593. What is this? What is this? 593 and 593. Two columns are equal, then the value of the determinant is 0. That's it. Very simple. Remember that two columns or two rows are identical, then the value of the determinant is 0. This appeared in the examination August 2019. Then one more problem. I think problem number 3. Prove that BC, CA, AB, B plus C plus A plus B, 1, 1, 1, equal to A minus B minus C minus A. We have to prove this thing. So see here. So I am writing left hand side. Left hand side. What is left hand side? BC, CA, AB, B plus C plus A plus B, 1, 1, 1. What I am doing is R1 implies R1 minus R2 I am taking. R2 implies R2 minus R3 I am taking. So this will be R1 first row minus second row. BC minus CA, B plus C minus A, 1 minus 1. Now CA minus AB, C plus A minus B, 1 minus 1. AB as it is, B plus B as it is 1. You can't apply more than 2 operations at a time. The rule says only 2 operations, either row or column. Both should be rows, both should be column. I am applying rows, both rows. If you want to apply column, it should be both column, not one row, one column. Please make a note. Now here C is common. I am taking C. It is B minus. If I take common B minus A, C getting cancelled. This is B minus A. 1 minus 1 is 0. 1 minus 1 is 0. From here, I can take A common. So C minus B, A getting cancelled, C minus B. 1 minus 1 is 0. This is AB, A plus B, 1. See here, please. From here, B minus A can common. I can take common. From here, C minus B I can take common. So what is our problem? Our problem is reduced to very things. So B minus A you have taken common. And here C minus B you have taken common. So what is left? AB and B minus A taken common means 1 is left. Here also 1, A plus B. 0, 0, 1. Now what we are doing? Expanding by C3. Why I am going for a C3? Because 2 or 0, only one last is left. So B minus A, C minus B, C minus B. So expanding by this if you expand, what will happen? This row and this column you have to leave. So what is left? What is left? This into this is C into 1 is C minus C minus A into 1 is C minus A. So this is, you see, if I take minus common, it will become A minus B. From here, if I take minus common, this become big. Minus into minus is plus. So A minus B, B minus C, C minus A, which is our right hand side. That's it. Without expanding, we got the proof using the properties. And this appeared in the exam May 2022. This is one determinant problem. Always determinant problems are coming in the exam. See next problem. Without expanding, show that 1, 1, 1, A, B, C, B plus C, A plus C, B plus A equal to 0. Without expanding, you have to show. So left hand side, what we are doing, I am doing R1 implies R1 minus R2 and R2 implies R2 minus R3. So this is left hand side, R1 1 minus 1, A minus B, B plus C minus A minus C. Last column is same, no change. So R2 implies R2 minus 1 minus 1, 1 minus 1, this is B minus C, this is A plus C minus B minus C. Now, 1 minus 1 is 0, 0, 1. This is A minus B, this is B minus C, C. This is C Z getting cancelled, B minus A. I am writing minus common A minus B. Okay. This is A got in C minus B. I am writing minus of B minus C. And this is B plus. Now, what I am doing is, see here, if you see here, A minus B is common here. And here B minus C is common. That's why we have taken minus common. So now A minus B, if I take common from the first row, and B minus C from the second row, 1 0 0 1, A minus B is 1, this is minus 1, B minus C is 1, this is minus 1, and this is C, this is B plus. What the rule says, two rows or two columns are identical, then the value of the determinant is 0. Identical means same. If two rows and two columns are identical, then the value of the determinant is 0. Therefore, answer is 0, which is our right answer. That's it. Very simple. Always one problem is there on the determinant. One more problem on the determinant. So another problem which says show that 1x x square, 1y y square, 1z z square equal to x minus y minus z, z minus x. Now here we have to prove these things. So left hand side. So what I am doing is C1 implies C1 minus C2. C2 implies C2 minus C3. I am doing this because this is column 1. So 1 minus 1 x minus y x square minus y square. 1 minus 1 y minus z y square minus z square. 1 minus z z square. So here 1 minus 1 is 0, 0, 1. Now x minus y. This, you remember, a square minus b square is a plus b into a minus b. So this is x plus y into x minus y. This will be y minus z, z, y minus z, y plus z, c square. Now what we are doing here, see here, y minus z, y minus z. And here x minus y, x minus y. So from the column 1, we are taking x minus y. From the column 2, I am taking y minus. So what is left? 0, 0, 0, 1. First row as it is now. From second x minus, sorry. First column x minus y. So 1, this is x plus y. From the second y minus z. 0, 1, y plus z. 1 z, z square. Now expanding by R1. Expanding by R1. This is 0, the last one. So if we expand by R1, this row, this row, this row and this column is gone. This row and this column. So what is left? What is left? 1 time AD minus BC. 1 time y plus z minus x minus y. Minus y plus y getting cancelled. So therefore x minus y y minus z minus x. That is our right hand side. That is our right hand side. Hence showed or proved it appeared in Jan 2020. Please make a note. That's it. That is for the derivatives. That is for the determinants. So I think I have done almost all the problems. I think I have done all the problems. Thanks for watching. Please do subscribe my channel and share with your friends.